लॉगिन लॉगिन हो गया। हेलो, गुड आफ्टरनून। Boys and girls, give me the clearance, please. Vijay, give me the clearance. Is it all clear? Rathod, yes, thank you so much. So very good afternoon to all of you. Welcome to Unacademy. Dr. Khalil Khan here. And welcome to Operating System नया आगाज सीरीज लेक्चर। और आज का सेशन होगा पेज रिप्लेसमेंट टेक्निक्स। काफ़ी इंपॉर्टेंट है, सिंपल टॉपिक है, इंटरेस्टिंग टॉपिक है एंड क्वाइट इंपॉर्टेंट फ्रॉम गेट एग्जाम पर्सपेक्टिव। तो पिछली क्लास में हमने वर्चुअल मेमोरी का कॉन्सेप्ट देखा, इम्प्लीमेंटेशन देखा, उसका परफॉर्मेंस इशू विथ रिगार्ड टू टेम्पोरल इशू हमने बात की, और आज हम देखेंगे पेज रिप्लेसमेंट टेक्निक्स। नाउ रिमेंबर एंड रिकलेक्ट, अगर आप पिछली क्लास से रिकलेक्ट करो, वी सेड दैट वर्चुअल मेमोरी गिव्स एन इल्यूजन to the programmer that a huge memory is available for executing programs that are greater than the size of available physical memory. वो possible है by using demand paging। मतलब virtual memory is implemented through demand paging. What is demand paging? Loading the pages on demand at runtime, maybe from secondary storage to main memory. That means the program is initially assumed to be stored on disk, on secondary storage in the form of pages. और जो pages आप initially load कर सकते हो memory में, आप load करेंगे, and those pages which cannot be loaded, they will be there on disk and they will be loaded in memory on demand at runtime by using a concept called page fault. So the essential aspect in the implementation of virtual memory है page fault. What is page fault? The event of referring to a page which is not present in memory is called page fault. So when a page fault occurs, a trap is sent to the operating system, and operating system gets trapped, and the operating system will identify the page through disk manager and will make a necessary arrangement to bring the faulted page into main memory. And when the time comes to bring the page in memory, I can have two sequence of events. So sometimes what happens is empty frame may be available, and otherwise sometimes empty frame may not be available. अगर empty frame available हो तो पेज रिप्लेसमेंट की कोई ज़रूरत नहीं है, और अगर empty frame ना हो then I need to go for page replacement. तो आज हम लर्न करेंगे बच्चों के what are the various page replacement techniques. We try to solve some problems और कुछ PYQs भी देखेंगे to consolidate your understanding. हाँ, अगर क्रैश कोर्स में everything will be covered, no problem. तो टू स्टार्ट द डिस्कशन ऑन पेज रिप्लेसमेंट एल्गोरिथम, सबसे पहले कुछ बेसिक कॉन्सेप्ट्स आपने अंडरस्टैंड करना है। वो सबसे पहला कॉन्सेप्ट ये है कि रेफरेंस स्ट्रिंग। व्हाट इज रेफरेंस स्ट्रिंग? बिकॉज ऑल द पेज रिप्लेसमेंट टेक्निक्स आर बेसिकली स्टडीड विद रिस्पेक्ट टू द कॉन्सेप्ट ऑफ रेफरेंस स्ट्रिंग। तो सबसे पहले रेफरेंस स्ट्रिंग का डेफिनेशन देखेंगे और फिर उसके बाद आगे बढ़ेंगे। रेफरेंस स्ट्रिंग मीन्स सेट ऑफ successively unique pages pages मतलब पेज नंबर। सेट ऑफ सक्सेसिवली मतलब सक्सेसिवली अगर सेम पेज आ रहा है तो एक बार ही लिखेंगे। सेट ऑफ सक्सेसिवली यूनिक पेजेस रेफर्ड in the given list of virtual addresses is called reference string. एग्जाम्पल लेके समझने से थोड़ा बहुत आसानी होगी, तो चलिए एग्जाम्पल लेंगे. Like imagine these are the list of virtual addresses जो प्रोसेस ने जनरेट किए. Like for example 853 or 852 followed by 936 followed by 012 followed by 122 followed by 125, then again 908, then 754, then again 754, then 850, like that it goes. यहां पर let us imagine for example page size is equal to 100 words. Page size देखिएगा is not a power of 2. Page size is 100, which is not a power of 2. So every virtual address, as you know, format of virtual address, every virtual address will have two parts. What are the two parts? Page number and offset. जब वर्चुअल एड्रेस 852 हो तो इसमें पेज नंबर क्या है और ऑफसेट क्या है आपने पता है. द फॉर्मूला फॉर पेज नंबर इज वर्चुअल एड्रेस डिवाइडेड बाय पेज साइज. And what is the formula for page offset? Page offset is virtual address modulo remainder page size. This is the formula for page number and offset when page size is not a power of 2. So using this formula हम यहाँ पर इस process की reference string generate करेंगे. Reference string. We'll generate the reference string. 852 देखिएगा 852 is a virtual address. So when I divide it by 100, I get the quotient as 8. So that is the page number. So therefore this is the page number 8. Next 936 divided by 100, page number 9. Next 012, so page number 0. Next page number 1. Next again 1. Successively अगर same page refer किया जा रहा है तो we write it only once. So therefore 1. Page number 1. 1. So therefore we are going to write again only one time. We are going to write only one time. फिर इसके बाद पेज नंबर आएगा 9, फिर उसके बाद पेज नंबर आएगा 7, फिर 7 is repeating, we write it only once, फिर उसके बाद 8 आएगा, इस तरह जाएगा. This is called the reference string of the process. तो हर एक प्रोसेस का अपना reference string होगा. With respect to reference string only, we are gonna study various page replacement techniques. तो before we start the page replacement techniques, एक और concept है जो आपने understand करना है, वो है फ्रेम एलोकेशन पॉलिसीज. देखिएगा टू अंडरस्टैंड दिस फ्रेम एलोकेशन पॉलिसी एक सिंपल पॉइंट ये है कि एवरी रेफरेंस स्ट्रिंग, हर एक प्रोसेस की जो अपने रेफरेंस स्ट्रिंग होगी, देयर आर टू एट्रीब्यूट्स ऑफ द रेफरेंस स्ट्रिंग. नंबर 1, लेंथ ऑफ रेफरेंस स्ट्रिंग. Length of reference string. Every process will have its own length of reference string. We denote it by L. Second important parameter is number of unique pages in reference string. Number of unique pages. We denote it as N, let us say. जैसे कि for example, for the previous example का अगर आप देखो, here the length of reference string is 1, 2, 3, 4, 5, 6, 7. Number of unique pages क्या है? 0, 1, 7, 8, 9. These are the number of unique pages. So 2 to 4, 5 unique pages. So these 5 unique pages define, maybe you can say size of process. This will define size of process. मतलब हम ये कहेंगे कि this process is defined in terms of 5 unique pages. मतलब process के 5 pages disk पर है. इसका मतलब ये भी हुआ कि you have to load these 5 pages into main memory. So that means the process is going to make a demand for 5 pages or 5 frames. So here the frame allocation policies का मतलब ये है कि when the process is making some demand, like for example if I write the demand of process for frames, is say some di, and here we say available frames in memory. Is let us say capital N. So this for I is equal to 1 to n, सारे 9 processes का डिमांड है. टोटल डिमांड आप बोलोगे व्हाट? टोटल डिमांड फॉर फ्रेम्स which is nothing but capital D is nothing but sigma di. I is equal to 1 to n. And generally the perception is the demand will be more than, the demand capital D will be more than the number of frames. When the demand is more than the number of frames, then you need to decide what is frames allocated to each process. The process has demanded some frames, DI frames. So how much should be given to it? That is indicated by some AI. To decide upon this AI, we have several frame allocation policies, like it may be equal allocation. That means every process will get equal number of frames. If not equal, it may be proportionate allocation. Proportional to the demand. अगर demand ज़्यादा होगा तो आप ज़्यादा दोगे, demand कम होगा तो कम दोगे. Proportionate allocation. And if not, you can even follow some policy like 50% rule. If you have enough frames, you can follow 50% rule. मतलब whatever the process is demanding, जो भी frames demand कर रहा है process, you can ask for, you can give 50%. So my dear students, boys and girls, with reference to referencing and some allocation policy, now we are ready to gear up. We are ready to start with to discuss the various page replacement techniques. तो चलिए start करते हैं सबसे पहले by taking some referencing. So I'm imagining the following referencing, boys and girls. So if you observe this referencing of the process, some hypothetical process, सबसे पहले हम बोलेंगे what is the length of reference string. What is the length of this reference string? If you observe total number of count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, I think one is missing. Just let me check. There is one page is missing, I suppose. So 701, 203, 0423, 0321, 201, 201, 701. यहाँ पे एक missing है. So I will just write it down again. 201, 701. 201, 701. Okay. So that is my reference string. So length of reference string, I am taking it like n is equal to 20. There are 20 references. Number of unique pages. How many unique pages are there? 0, 1, 2, 3, 4 and 7. Look at that. 0, 1, 2, 3, 4 and 7. So therefore there are 6 pages. इसका मतलब ये है कि this process is defined in terms of 6 pages. What are the 6 pages? 0, 1, 2, 3, 4 and 7. तो मतलब ये हुआ कि this process is stored on disk in the form of 6 pages. Means it will ask for 6 frames. लेकिन generally हमने कहा the process may be given less than 6 frames, maybe 3, maybe 4, maybe 5, or maybe worst case it can be given 6 frames. So imagine, for example, this process is given, let us say 3 frames. We'll follow like this. This process is given 3 frames, something like this. Okay. चलो स्टार्ट करेंगे. Look at this. So initially we are assuming pure demand paging. These are the 3 frames. The status of the 3 frames is shown here. And we are following, for example, pure demand paging. We are following pure demand paging. Pure demand paging का मतलब ये है कि initially the program will start with all empty frames. Program का जो execution होगा, it will start with all empty frames like here. So what is going to happen? Initially I am going to refer 701, the 3 page faults होंगे. So we are going to load 701, no replacement. हमने कहा as long as there are empty frames available, initially all frames are empty. So I don't need any replacement. 701 I will load it. Next, look at this. I am causing page fault for 2. I am referring to 2 causing a fault. Now I don't have 2 in the main memory. So हमें decide करना होगा among 701 who is going to be replaced. Among 701 who is going to be replaced. So what are the possible replacement techniques? The first replacement technique is called natural approach of replacement FIFO. First in, first out. मतलब जो भी पेज पहला आया उसकी जगह I am going to bring the faulted page. In place of it, I am going to bring the faulted page. तो सबसे पहले जो पेज हमने लोड किया that was 7. So we are gonna replace 7 in place for 2. So now my status is 201. Next, 0 is not going to cause a fault. 0 के बाद 3 will cause a fault. 3 will cause a fault. तो 3 की जगह कौन, मतलब 3 के लिए कौन replace होगा? Among 201, 0 is the first one to come. So in place of 0, I am going to bring 3. 2, 1. Then after that, 0 will again cause a fault. So who is the victim? Victim is 1. So in place of 1, I am going to bring 0. So now status is 230. Next, 4 will cause a fault. 4 will be replacing 2. So 4 यहाँ पे आएगा. 30 as it is. Then after that, 2 will cause a fault. 2 will be replacing 3. So therefore, I will have 420. Then after that, 3 will cause a fault. Then that will be replacing 0. So I will have 423. Yes, status है. Then after that, check. 0 will cause a fault. 0 will be replacing 4. So 0, 2, 3. फिर इसके बाद क्या होगा देखिएगा 3 and 2 are present in memory. There is no page fault. इसके बाद 1 रेफर करेंगे will cause a fault and that will be replacing 2. So in place of 2 I am going to bring 1. Then after that 2 will cause a fault. 2 will be replacing 3. So 0, 1, 2. Then 0, 1 both are present in memory, no page fault. Then after that देखिएगा 7 will cause a fault. Will be replacing 0. So 7, 1, 2. इसके बाद 0 will cause a fault, will be replacing 1. So 7, 0, 2. Last में देखिएगा 1 will cause a fault. So I will have 7, 0, 1. This is a scenario. So if I take 3 frames, boys and girls, if I take 3 frames, how many page faults it is going to cause? 2 plus 2, 4, 6, 8, 10, 12, 13, 14, 15 page faults. तो इसके हिसाब से पेज फॉल्ट रेट P आप क्या बनाओगे 15 by total references 20. So this become 3 by 4. So therefore 75%. So if I with 3 frames, the number of page faults are 15. That is 75% page fault rate. Boys and girls, can you tell me in the chat box? क्या आप मुझे बताओगे chat box में what is going to happen if I take 4 frames? अगर process को 3 frames के बजाय अगर हम 4 frames देंगे, how many page faults will be caused? Can you work out? Can you calculate and let me know the answer, please? How many page faults will happen if for the same reference string, if I go for 4 frames? Come on, work out. Siddhi Rathod, Vijay, Raj FC, Mr. Ghosh. Please work out and let me know how many page faults will happen if I take 4 frames. चलिए मैं भी साइमल्टेनियसली करूंगा आपके साथ यहां पर, आप भी अपने लेवल पे कीजिएगा. सो हियर आई एम गोना टेक 4 frames. And try to work out for number of page faults. Check. So let me remove this. चलिए. So initially 7012, 7012, 4 page faults. Pure demand paging. अब इसके बाद we are referring to 0, there is no page fault. We are referring to 3 will cause a fault. तो हमें डिफाइड करना होगा who is going to be the victim. देखिएगा सबसे पहले हमने 7 ब्रिंग की थी. So in place of 7, we are going to bring 3. Now first in first out page is 0. Remember that. After that 0 is referred no page fault. 4 will cause a fault. So who is the victim? Victim is 0. So in place of 0 we are going to bring 4. Now remember 1 is the victim. 1 is the first in first out page. 2 and 3 both are present in memory, no page fault. 0 will cause a fault. So therefore we are going to bring 0 in place of 1. in place of 1. Now remember 2 is the victim. Then thereafter 3 and 2 both are present in memory, so no page faults, right? After that 1, 3, 2, 1, 3, 2, 1 all are available. Then after that 2 again will not cause a fault, 0 will cause a fault, 0. So who is the victim? 2 is the victim. So in place of 2 we are going to bring 0. 1 will not cause a fault, 7 will cause a fault. So the victim is 3. So in place of 3 we are going to bring 7. Then after that 0 and both are present, 2, 3, 4, 5, 6, 7, 8, 9, 10 page faults, right? So page fault rate, if you observe P is equal to 10 by 20 and hence 50%. Page fault rate has decreased. Page fault rate has decreased. That is correct. 6 plus initially 4. 6 plus 4, 10 page faults. So boys and girls, that is the way it works. Now the question is, does it always increase? I mean, what I am trying to say, what I am trying to make you understand, अगर आप graphically समझने की कोशिश करो, say for example here is the y-axis and this is the x-axis. On x-axis, suppose if I say, on x-axis if I say number of frames, and on y-axis, suppose if I say page fault rate, origin 0. So if I increase the number of frames on x-axis, the page fault rate should logically decrease. The page fault rate should decrease. So that means how should the curve, how should the graph look like? What is the nature of the graph for this particular scenario? The nature of the graph is it's a decreasing curve and then it becomes constant. It's a decreasing function like this, right? So these are threshold K. जहाँ पर number of page faults will also be same. If I have K frames, like previous example, there are six pages. So if I have 6 pages and 6 frames, the number of page faults using pure demand paging will be 6. It will not be more than that. So 6 के बाद जितने भी number of frames additional आप allocate करो, the number of page faults will always be same, right? But the point is, do page fault rate always decrease as you increase the number of frames? जैसा आप number of frames increase करोगे, क्या page fault rate हमेशा decrease ही होगी? ये question है. तो उसके लिए एक और reference string लेते हैं यहाँ पर. We'll take another reference string and try to study it. Reference string 2. Let's say 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. Consider this reference string. 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. This is a reference string. For this reference string, I want you to please work out and tell me, for this reference string, let me draw a line here. ये reference string के लिए, please work out and tell me using FIFO replacement. Using FIFO replacement, boys and girls. Using FIFO replacement, pure demand paging, 3 frames से कितने page faults होंगे और 4 frames से कितने page faults होंगे? Please work out and let me know. Please work out and let me know. With 3 frames, how many page faults and 4 frames, how many page faults? सबसे पहले 3 frames से workout कीजिएगा please. Workout with 3 frames. मैं भी यहाँ पे करूँगा आपके साथ. These are 3 frames. Okay. So first in, first out. So initially I will have 3 page faults, 1, 2, 3. 3 frames. Number of frames are 3. Vijay. Then after that 4 will cause a fault. Will be replaced by 1. So 1 की जगह 4 आएगा. Then after that 1 will cause a fault. Will be replacing whom? 2. So 1. 2 will cause a fault. Will be replacing 3. Now I have 4, 1, 2. Then after that 5 will cause a fault. Will be replacing 4. So 5. Then 1 and 2 will not cause a fault. 3 will cause a fault. Will be replacing 1. So 3 आएगा यहाँ पर. फिर उसके बाद 4 will cause a fault, will be replacing 2. Then 5 will not cause a fault. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 page faults. 3 frames के साथ 9 page faults हुए हैं for this reference string. For this reference string, 3 frames के साथ 9 page faults हुए हैं. I want you to verify and tell me. I want you to verify and tell me 4 frames. If I take 4 frames, boys and girls, here I'm going to take. If I take 4 frames, how many page faults will occur? Come on, do it. आप करिए. You do it. Let's take 4 frames. Like this. Come on, do it. I'll give you a minute of time. 4 frames के साथ how many page faults will occur with first in first out replacement? With first in first out replacement, how many page faults will occur with 4 frames? Come on, do it and let me know. I think Vijay 6 is not correct. Do it again, Vijay. It is not 6. 4 frames के लिए how many page faults will happen? I hope you are doing. Because based on this, एक हम important point conclude करेंगे. So please work out. Unless you work out, you cannot conclude that important point. 3 frames we have proved 9 page faults. With 4 frames, how many page faults? That's right, Siddhi. Siddhi is correct. 4 frames के साथ 10 page faults होंगे. Let us work out. Let us work out. So initially, like earlier occasion, 1, 2, 3, 4, 4 page faults. 1, 2, 3, 4, 4 page faults. इसके बाद देखिएगा 1, 2 will not cause a fault, 5 will cause a fault. So 5 किसकी जगह आएगा? 1 की जगह आएगा. Then 1 will cause a fault, 1 किसकी जगह आएगा? 2 की जगह आएगा. Then 2 will cause a fault, 3 को replace करेगा. Then after that 3 will replace 4. Then after that 4 will replace 5. इसके बाद 5 will replace 1. So how many page faults? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 page faults. So boys and girls, 10 page faults. So what is the conclusion? The conclusion is, please observe, यहाँ पर with 3 frames 15 page fault, with 4 frame page fault 10 page faults, means page fault rate has decreased and it is obeying the natural characteristic. लेकिन second example में ये हुआ है कि with 3 frames 9 page faults and 4 frames 10 page faults, means page fault rate has increased and this is going against the natural characteristic. This is going against the natural characteristic. Natural characteristics. Anything that goes against natural characteristic is called anomaly. And this anomaly of page replacement was observed by a person by name Belady's anomaly. This anomaly of page replacement was observed by Belady's anomaly. So let us write the definition of Belady's anomaly. So point number 1, we could say that generally, in general, with the increase in number of frames, page fault rate decreases. A natural convention with the generally. But however, for few reference strings, with the increase in number of frames, page fault rate also increases. Page fault rate also increases. This phenomena is known as Belady's anomaly. This concept or phenomena is known as Belady's anomaly. एक और बात याद रखना है कि FIFO and FIFO based random replacement techniques suffers from Belady's anomaly. Suffers from Belady's anomaly. Only FIFO and FIFO based and random replacement are bound to suffer from Belady's anomaly. इसके पीछे theory है that we don't have to go for the theory कि Belady's anomaly क्यों होती है. We don't have to venture into it. Actually, there is something called stack replacement or page replacement के लिए एक stack property है. So that stack property satisfaction dissatisfaction basically incur Belady's anomaly. So we don't have to really go from the perspective of gate. तो ये है बच्चों FIFO and its corresponding Belady's anomaly. Let us now proceed to the other replacement technique. What are the other replacement techniques, right? Just a second. So I will take the same reference string which I took earlier and we try to study the other replacement techniques. Okay? So let's study this. I take the same reference string. Okay, let me copy it here. Seven 701 203 0423 0321 201 701. These are reference string. So in respect of this reference string, let us see the other replacement technique. The second one is called optimal replacement. This optimal replacement algorithm was proposed by a person, same person, Belady, and hence it is called Belady's optimal replacement. Optimal, as the name implies, it is going to generate the least page fault rate. सबसे कम page fault rate generate करेगा. So when will that happen? Optimality कब आएगी? यहाँ पे देखिएगा optimal replacement algorithm का एक note है. In this algorithm, pages are replaced which would not be used for the longest duration of time in the future. Look at that. The pages which will not be used for the longest duration of time in the future. Which would not be used for the longest duration of time in the future. It is also known as Belady's optimal page replacement policy. तो सबसे पहले before we look into the other comment, we will work out here. जब भी page fault होगा, we are going to select that page which will not be used for longest duration of time in future references. तो चलिए workout करते हैं. 3 और 4 frames से how many page faults are going to get generated? 3 and 4 frames से how many page faults will get generated? So I'll work out with 3 and you are going to work out for 4 frames and let me know. 4 frames से आप workout करके मुझे बताएंगे how many page faults will occur. मैं 3 से करूंगा. Check. So these are the frames. Initially, as usual, I refer 701. Look at this. I refer 701, 3 paid faults. Then we refer 2. 2 will cause a fault. अब हमें decide करना है, यहाँ पे थोड़ा बच्चों को confusion होता है. So I would request you please follow carefully. When I'm referring page 2, page fault is occurring. I don't have 2 here. So अब हमें decide करना है among 701 which one is going to be victimized. कौन सा page should get victim. तो हमें क्या करना होगा, future references में देखना होगा और decide करना है कि among 701 सब कौन सा page end में आ रहा है, last में. तो we are referring 0, keeping on scanning 1. 7 is occurring at the end. देखिएगा, तो in place of 7, we are going to bring 2. Then after that, 0 will not cause a fault, 3 will cause a fault. तो हमें decide करना है among 201 who is going to be the victim. अब देखिएगा, 0 is referred, 2 is referred, 1 is at the end. So in place of 1, we are going to bring 3. Optimal replacement. 0 will not cause a fault, 4 will cause a fault. हमें decide करना है 203 में कौन victim है. 230 जो end में refer हो रहा है 0. So in place of 0, we are going to bring 4. Then 2, 3 both are present in memory, no paid fault. 0 will cause a fault. So in place of 0, 3, 2 are referred. 4 is not referred. Why should I hold it? So in place of 4, we are gonna bring 0. 2 and 3 both are referred, no paid fault. फिर उसके बाद 1 will cause a fault. 2 अब देखिएगा 1 because 3 and 2 are present, 1 is not present. So 2, 0 are referred, 3 is not referred. So therefore in place of 3, we are going to bring 1. Then after that 2, 0, 1 all are present. 7 will cause a fault, 0, 1. So therefore 2 is not referred. So in place of 2, we are going to bring 7. A very natural policy. Then after that 0, 1, no paid fault. So with 3 frames, boys and girls, for optimal replacement, with 3 frames, if you see, कितने paid fault बने? 2, 2, 4, 5, 6, 7, 8, 9. 9 paid faults. 3 frames, 9 paid faults. Can you work out with 4 frames and let me know how many paid fault, boys and girls? Can you work out with 4 frames and tell me how many paid faults will happen with optimal replacement? जल्दी workout करके बताइएगा please, and make sure that your practice is on track. Four frames, 8 paid faults. Very good, Vijay. I am also working out. आप भी वर्कआउट कीजिएगा. मैं भी वर्कआउट कर रहा हूं, आप भी कीजिएगा. 4 frames. So I'm working out here for 4 frames. Check. Initially 7012, 7012, 4 paid faults. 70142. आशीष अग्रवाल, good evening. 15 कहां से आएगा? Then after that 0 will not cause a fault, 3 will cause a fault. कौन आएगा 3 की जगह? 3 की जगह किसको रिप्लेस करेंगे? Decide. 0, 2, 1 is referred. 0, 2, 1, 7 is at the end. So in place of 7, we are going to bring 3. 0 is referred, no paid fault. 4 is referred and causing a fault. So decide करना होगा 2, 3, 0, 1. 1 is at the end. So in place of 1, we are going to bring 4. Then 2, 3, 0. 2, 3, 0 are no paid fault. 2, 3, 0. फिर 3, 2 also no paid fault. फिर 1 will cause a fault. 1 will cause a fault. हमें decide करना होगा 2, 0, 2, 0 referred. 2, 0. Then 3 and 4 are not referred. 3 and 4 में से कोई भी एक को आप replace कर सकते हो. I will replace 3. So in place of 3, I am going to bring 1. 2, 0, 1, 2, 0, 1 are referred, no paid fault. Then 7 is referred. 7 will cause a fault. 0, 1 is referred. 4, 2 में से कोई भी एक आप replace करो to bring 7. 0, 1 will not cause a fault. ये है 2 to 4, 5, 6, 7, 8. 8 paid faults. 8. ये है approach. What I suggest is as a matter of practice, what I suggest, ये जो second referencing हमने देखा था, इसके लिए यूजिंग ऑप्टिमल रिप्लेसमेंट। चलिए ऑप्टिमल रिप्लेसमेंट 3 फ्रेम्स और 4 फ्रेम्स वर्कआउट करके चेक कर लेते हैं और देखेंगे कि बेलाडीज एनोमली होगी या ना होगी। Whether Beladi's anomaly happens or not, let us verify just with one more replacement technique optimal. Just with one more replacement. So here I'm going to work out. ठीक है? Second, optimal replacement. Optimal replacement. 3 frames. So first I will take 3 frames. Let's imagine these are the 3 frames. चलिए, I'm doing it. Please follow me, boys and girls. 3 frames. Can you tell me how many page faults are going to happen? So initially 1, 2, 3. I'm doing for second referencing optimal replacement 1, 2, 3. 3 page faults. Then after that 4 will cause a fault. हमें decide करना होगा among 1, 2, 3 who is going to be victim. 1, 2, 3. 3 is going to be victimized. In place of 3 we are going to bring 4. Then 1, 2 are referred. 5 will cause a fault. तो देखेंगे 1, 2, 4. 1, 2, 4 is at the end. So in place of 4 we are going to bring 5. Then 1, 2, 1, 2. 3 is going to cause a fault. 4, 5. 5 is referred. So 1 and 2 की जगह let's say in place of 1 I am going to bring 3. उसके बाद देखिएगा 4 will cause a fault. 4 will cause a fault. So 4 की जगह we bring 2 let us say. 4. 4 will cause a fault. So 2 to 4, 5, 6, 7, 7 page fault. 3 frames, 7 page faults. 4 frames अगर आप workout करो, 4 frames if you work out this, how many page faults will happen? Let us try to see it here below. 4 frames. I'm doing it here. चलो स्टार्ट करेंगे। चेक। इनिशियली 1, 2, 3, 4 4 page faults, 4 frames, optimal replacement 1, 2, 3, 4 4 page faults. Then after that 1, 2 will not cause a fault, 5 will cause a fault, 5 will cause a fault. अब देखिएगा 1, 2, 3, 4 4 is at the end. So in place of 4 I am going to bring 5. 1, 2, 3 no page fault, 4 will cause a fault. That's it. तो 5 को हम replace नहीं करेंगे. So 4 I bring it in place of this. So 2 to 4, 5, 6 6 page faults. 6 page faults. Page fault rate decreased. So that means ये है कि Beladi's anomaly do not happen with optimal replacement. Beladi's anomaly does not occur for optimal replacement. यही referencing के लिए FIFO was suffering from optimal replacement, but Beladi's anomaly does not happen for optimal replacement. ये proof है. So that's the way it works. चलिए अब next problem with optimal replacement. What is the drawback with optimal replacement? The drawback of optimal replacement is this is practically non-implementable. Practically non-implementable. Why? Because you cannot look into the future references. जब आप एक particular page को refer कर रहे हो, in future what pages are referred we don't know. So we cannot predict the future. Hence optimal replacement, just like shortest job first, is non-implementable. Then why do we use it? The reason for using it is the same as we saw earlier. It is used as a benchmark to measure the performance of other algorithm. Benchmark. To make performance comparison among different algorithms to find out which algorithm is superior or efficient. That is the reason for having optimal replacement. Then what can be implemented which is quite opposite to optimal replacement? So the exact opposite to optimal replacement is you can go for a scheme like LRU, which stands for least recently used. Least recently used. Exact opposite to optimal. You cannot look into the future, but you can look into the past. अगर आप past पे देखते हुए जो apply करोगे concept like optimal, then that is called least recently used. So let's study least recently used algorithm for the same reference string. यहाँ पे वो ये देखेगा optimal page replacement algorithm is difficult to implement because it is dependent on future pages or future references, but it will give you the best possible results, right? So despite this limitation, algorithms exist that can offer near optimal performance. Optimal performance के near रहेगा, and that is nothing but algorithm like least recently used. So how are we going to follow the least recently used algorithm? Let us try to see here. So I take the same reference string again. I have to keep on copying because there is no option for copying the content. So let us take the same reference string 701 203. Just let me review it. 203 0423 0423 0321 201701. These are reference string. ठीक है? Let's study LRU algorithm with respect to this. With respect to this reference string 2 to 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah. So third replacement technique is LRU, least recently used. I have seen people going into confusion with this. So boys and girls, please follow carefully. In the event of page fault, victimize the page which has been referred for the longest duration of time in the past. जो past में सबसे आखिर में आएगा पेज, वो पेज replace किया जाएगा LRU. So I'm going to make a trace for 3 frames and you are going to work out for 4 frames. You are going to work out for 4. So 3 frames से हम यहाँ पे workout करेंगे. चलिए start करेंगे. So initially what is going to happen, I have 701 3-page faults. 701 3-page faults. So now boys and girls, please observe that 1 is most recently used. Before that 0, 7. 7 is least recently used. जो पेज सबसे आखिर में आएगा 701, right? 1, 701. 7 is at the end. So 7 is LRU. फिर इसके बाद कौन रेफर होगा? 2 will it cause a fault? हाँ, 2 will cause a fault. 2 will cause a fault. So who is going to be victimized? 1 or 0 or 7? 7 is at the end. So in place of 7, we are going to bring 2. Then 0 won't cause a fault. 0 is available. 3 will cause a fault. Who is the victim? देखिएगा 0, 2, 1. 1 is at the end. So in place of 1, we are going to bring 3. Then 0 is available, no page fault. 4 will cause a fault. 0, 3, 0, 2. 2 is at the end. So therefore, in place of 2, we are going to bring 4. 2 again will cause a fault. 4, 0, 3. 3 is at the end. So therefore, in place of 3, we are going to bring 2. उसके बाद देखिएगा 3 will cause a fault. 2, 4, 0. 0 is at the end. So therefore, 2, 4, 0. 0 की जगह आप लाओगे page 3. 0 will cause a fault. 3, 2, 4. 4 is at the end. So in place of 4, we are going to bring 0. 3 and 2 both are present in memory, no page fault. 1 will cause a fault. Who is the victim for 1? 2, 3, 0. 0 is at the end. So in place of 0, we are going to bring 1. Then इसके बाद 2 will not cause a fault. 0 will cause a fault. 0 will cause a fault. तो 0 की जगह कौन आएगा? 2, 1, 3. 3 is at the end. 3 की जगह आएगा 0. Then 1 will not cause a fault. 7 will cause a fault. 1, 0, 1, 0, 2. 2 is at the end. So therefore, in place of 2, we are going to bring 7. ये है philosophy of LRU. So 0, 1 both are present, no page fault. So number of page fault calculate कीजिएगा 2, 4, 6, 8, 10, 12. 12 page faults. 3 frames. Number of page faults are 12. Can you please work out and tell me quickly with 4 frames using LRU How many page faults? Vijay has already done. Very good. 4 frames, how many page fault? Please, boys and girls, work out and let me know. 4 frames के साथ कितने page faults होंगे? सिद्धि राठौड़, where what happened? फिर से एक बार एक्सप्लेन. ठीक है, एक बार 4 frames के साथ फिर से करते हैं. सिद्धि, प्लीज ऑब्जर्व. I will work out with 4 frames again. ठीक है, 4 frames के साथ वर्कआउट करते हैं. जो भी आपका कंफ्यूजन हो देख लीजिएगा. Four frames. So those who have confusion, I'm doing for 4 frames. Please have a look on board. Check. Initially 7, 0, 1, 2, 4 page faults. 4 page faults. Check on board. 0 won't cause a fault, 0 is available. 3 will cause a fault, 3 will cause a fault. अब इसके लिए देखेगा कौन होगा. मतलब among 7, 0, 1, 2 हमें डिसाइड करना होगा who is the victim. तो उसके लिए हम क्या करना है? We have to look into the past and see who is occurring among these. ये जो पेजेस है इसमें सबसे आखिर में कौन आ रहा है? पहले तो 0 आ रहा है, so we are not going to touch. उसके बाद 2 रेफर हो रहा है, 1 भी रेफर हो रहा है, 7 is at the end. Among 7, 0, 1, 2, observe 7, 0, 1, 2. Who is occurring at the end? 7. So in place of 7, we are going to bring 3. Is it okay, Siddhi? Next. 0 won't cause a fault, 0 is present. उसके बाद 4 रेफर हो रहा है, will cause a fault because 4 is not present. तो डिसाइड कीजिएगा. आप देखिएगा 0 is referred, 3 is referred, again 0. then उसके बाद 2 है, 2 के बाद 1 है, 1 is occurring at the end. Look at that. Among this sequence 3, 0, 1, 2. 3, 0, 1, 2 यहां से देखना होगा. 3 यहां से 4 अभी रेफरिंग ना, तो 0, 3, 0, 2, 1. 1 is at the end. So in place of 1, we are going to bring 4. In place of 1, we are going to bring 4. सही है? यहां तक क्लियर है सिद्धि? समझ आ गया ना? ठीक है, कंप्लीट कर लेते हैं. नो प्रॉब्लम, विल कंप्लीट इट. चेक. फिर उसके बाद देखिएगा 2 and 3 both are present, 0 is also present, 3 and 2 again present, no page fault. फिर उसके बाद 1 will cause a fault. तब डिसाइड करेंगे 2, 3, 0. 2, 3, 0 तो रेफर आ रहा है, 4 बहुत आखिरी में है. So in place of 4, we are going to bring 1. Then after that 2, 0, 1 present, 2, 0, 1 present. 7 will cause a fault. So 7 replace होगा 1, 0, 2, 3. 3 is at the end. 3 is at the end. 3 की जगह आएगा 7. 0, 1 won't cause a fault. तो कितने पेज फॉल्ट बने? 2, 2, 4, 5, 6, 7, 8. 8 पेज फॉल्ट्स. 8 पेज फॉल्ट्स. ये है अप्रोच. हाँ, इसका सिमेट्रिक ऑपोजिट अगर आप करोगे, एमआरयू होगा, एल्गोरिथम जो होगा एमआरयू. मोस्ट रिसेंटली यूज्ड. दिस स्टैंड्स फॉर मोस्ट रिसेंटली यूज्ड. एमआरयू मतलब आई विल जस्ट स्टार्ट ऑफ, बाद में आप अपना कंप्लीट कीजिएगा. आई विल जस्ट स्टार्ट ऑफ एमआरयू, आप उसका फिर बाद में कंप्लीट कर लीजिएगा. 3 फ्रेम्स से मैं थोड़ा सा एक्सप्लेन करूंगा and then later part you should complete it. So imagine these are the 3 frames for MRU. For this reference string only I will make a trace with MRU most recently. तो चलिए स्टार्ट करते हैं. Initially 701 3 page faults. 701 3 page faults. Then after that 2 will cause a fault. So MRU से कौन victim होगा? When I apply MRU, who is going to be the victim? Just before 2 हमने कौन सा पेज रेफर किया? 1. So 1 is most recently used. So in place of 1, we are going to bring 2. फिर 0 will not cause a fault, 0 is available. 3 will cause a fault. 3 से पहले हमने कौन सा रेफर किया? 0. So 0 is victim to bring 3. फिर उसके बाद देखिएगा 0 will cause a fault, 0 is not present, so 0 की जगह कौन आएगा? 0 के बजाय, I mean most recently used, we have referred 3. So in place of 3 we are going to bring 0. Next 4 will cause a fault. Who is the victim? 4, 0. Just before 4, which page? Most recently used. So 0. So in place of 0 we are going to bring 4. Then 2 will not cause a fault, 2 is present. Then we refer 3 will cause a fault. Who is the victim? 2. So in place of 2 we are going to bring 3. इस तरीके से जाएगा. ये है most recently used. So you can continue and calculate how many page faults occur with most recently used. So boys and girls, these are some of the important replacement techniques. कुछ और भी replacement techniques है, आप study कर सकते हो. Those are like counting algorithms, least frequently used, least most frequently used. That I leave it for you to study because they are very simple. Okay, frequency मतलब number of times when a page fault occur. Least frequently used मतलब जो पेज जो सबसे कम यूज हुआ है number of times, और most frequently used मतलब वो पेज which has been most frequently used, सबसे ज्यादा times यूज किया गया है, वो most frequently used. So boys and girls, among all these algorithms, it is found that most of the time the performance of optimal replacement is closer to the performance of LRU is closer to optimal, and hence they go for implementation of most of the time LRU implementation. Then there is another important performance issue with regard to what we call virtual memory, और वो है the concept of thrashing. थोड़ा सा टाइम इस पर स्पेंड करेंगे. What exactly is thrashing and what are the causes for thrashing? Thrashing का बेसिक डेफिनेशन है एक्सेसिव और हाई पेजिंग एक्टिविटी. एक्सेसिव और हाई पेजिंग एक्टिविटी. सर ये पेजिंग एक्टिविटी क्या है? पेजिंग एक्टिविटी का मतलब क्या है? लेट अस अंडरस्टैंड. The act of causing a page fault, paging activity मतलब the act of causing page fault that involves loading and saving the pages. Loading and saving the pages is called paging activity. Invariably, अगर शॉर्ट में आप कहने के लिए कहो तो thrashing is nothing but very high page fault rate. Very high page fault rate of processes. जब processes की page fault rate shoot up हो जाएगी, become very high, that state is called thrashing. Thrashing like deadlock is undesirable, क्योंकि जब thrashing हो जाएगी सिस्टम में, thrashing बढ़ जाएगी या number of page fault rate बढ़ जाएंगे सिस्टम में, then processes get blocked and CPU is bound to be idle. So therefore it is going to have an impact. It is going to have an impact. Thrashing will have an impact on the throughput or efficiency. Throughput or efficiency पे impact होगा. So therefore thrashing like deadlock is undesirable and we must have strategies for dealing with thrashing. Strategies discuss करने से पहले we have to see what are the causes for thrashing, reasons for thrashing. Reasons for thrashing. Essentially, there are two important reasons. Number one, high degree of multi-programming. जब degree of multi-programming shoot up हो जाएगी, then eventually what will happen? Lack of frame allocation to process will decrease. Lack of frames, lack of memory. This situation can be demonstrated. This situation can be demonstrated by means of a simple graph. ठीक है? Generally what happens is if you increase the degree of multi-programming, if you mark degree of multi-programming on x-axis and on y-axis you say percentage CPU utilization. Percentage CPU utilization. So as you increase the degree of multi-programming, the utilization will also increase and reaches to some top. And after that it remains constant and then it starts declining. So this is the highest degree of multi-programming where you can achieve the maximum utilization of CPU. So ideally speaking, जैसे आप degree of multi-programming, if you keep on increasing beyond that threshold lambda, यहाँ से आप जैसा आप बढ़ाते जाओगे in degree of multi-programming, the lack of memory will happen, memory frame allocation will start declining to the processes, and page fault rate starts increasing, CPU starts sitting idle. So this state in the system is termed as thrashing state. This state in the system is termed as thrashing. There are other reasons also that contribute to thrashing. There are other reasons that can contribute to thrashing. Like for example, the other reasons could be like page replacement technique, the selection of appropriate page replacement technique play a role. अगर आप एक अच्छी टेक्निक यूज नहीं कर रहे हो तो पेज फॉल्ट रेट बढ़ेगा. Page size will also have an impact on thrashing. Larger page size, smaller page size. Page size is large, number of pages become less, number of page fault may become less. Page size is small, number of pages may become more, page fault rate may become more. Then appropriate data structures and programming techniques will also help control thrashing. Data structures and techniques will also help control or increase or decrease thrashing. So these are some of the reasons. Like we can demonstrate by means of a simple example. If process does not have, look at the notes, if process does not have enough pages, the page fault rate become high. This leads to low CPU utilization. This leads to low CPU utilization. Okay. Therefore, the operating system decides to increase the degree of multi-programming or thrashing बढ़ेगी जिसकी वजह से. So this is a phenomena that shows thrashing state. So जब thrashing होगी तो low utilization of CPU, memory utilization is superior, page fault rate is also superior. So this is an example for thrashing. ठीक है? So now the question is how to control thrashing. Thrashing control strategies. Thrashing control strategies. So essentially you can say that the control strategies, thrashing control strategies can be grouped into two types. I can have like preventive approach, or I can even go for detection and recovery. Two approaches like deadlocks. It can be easily prevented by controlling degree of multi-programming. Control degree of multi-programming. Very simple. Never allow the system, देखिएगा previous diagram में. Never allow the system to increase the degree of multi-programming beyond lambda. So hover around, fluctuate around in and around lambda. Therefore, you can ensure the system is under control. Otherwise, if you detect that the system is thrashing, अगर आपने detect किया, that means low utilization of CPU, high degree of multi-programming, and high paging disk utilization, system is thrashing. Then what do we do? Recover. How recovery is done? The only way you can recover the system is by applying process suspension. Suspend some of the partially completed processes from memory to disk. Process suspension from memory to disk. Memory to disk. So this is the essential approach of thrashing control. So this is the mechanism and the method for controlling thrashing. So invariably this completes the virtual memory. So we can stop here and continue in the next session with file system. So next session जो होगा मैं start करूँगा file system, interface, file system, implementation aspects. Implementation में मैं बात करूँगा allocation methods, free space management and disk scheduling techniques. तो देखेंगे next session में. Till then, thank you and continue your good learning experience.